Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 8 of CIE P3 9709 May June 2021 paper 3 variant 3. Alright, so the question says that the diagram shows the curve y is equals to ln x divided by x raised to the power 4 and its maximum point m. So the requirement of part A is to find the exact coordinates of m. Alright, so since we want to find the maximum point, so obviously, first of all, we need to find dy over dx and we will equate it with 0. And since we know the fact that the equation of the curve is in the form of y is equals to u over v, so u is equals to ln x, therefore u dash will be equals to 1 over x. And v is equals to x raised to the power 4, therefore v dash is equals to 4x cubed. So as we know the fact that when equation of the curve is in the form of y is equals to u over v, then dy over dx is equals to vu dash minus uv dash completely divided by v square. All right, vu dash minus uv dash divided by v square. So you need to remember this pattern. All right, otherwise this formula is also given to you in the formula sheet. So dy over dx will be equals to x raised to the power 4 times 1 over x and then minus u times v dash, which is supposed to be ln x multiplied by 4x cube, and then it is completely divided by v square, meaning x raised to the power 4 is squared. And what we need to do, we need to equate dy over dx with 0 because we need to find the maximum point. All right, so dy over dx is equals to x raised to the power 3 minus 4x cubed times ln x completely divided by x raised to the power 8, and this whole thing is equal to 0. So therefore x raised to the power 8 will be multiplied by 0. Therefore x cube minus 4x cube times ln x is equals to 0. So therefore we can factor out x cube. So taking x cube as common, multiplied by 1 minus 4 ln x, and this whole thing is equal to 0. So in order to solve this equation, first of all, x cube is equal to 0. So therefore x is equal to 0. But this will be rejected. This will be ignored since we are interested in finding the x coordinate of m, and obviously it is other than 0. So therefore x is equal to 0 is rejected. And then 1 minus 4 ln x is equal to 0. Therefore 1 is equals to 4 ln x. Therefore ln x is equals to 1 over 4, and therefore x is equals to e raised to the power 1 over 4. So this is the exact x coordinate of m. And obviously we need to find the corresponding y coordinate as well, and for that purpose we will substitute this value of x into the equation of the curve. So therefore y is equals to ln e raised to the power 1 over 4 divided by e raised to the power 1 over 4 is raised to the power 4. So therefore y is equals to 1 over 4 times ln e divided by e, and since you know that ln e is itself equals to 1, therefore y is equals to 1 over 4 is divided by e. So therefore the exact coordinate of y is equals to 1 over 4e. So therefore the exact coordinates of point m are e raised to the power 1 over 4 comma 1 over 4e. This is supposed to be your final answer to part A. Alright, so now we will solve part B. So first I'm going to erase the working of part A. I hope you guys have already copied the working. Otherwise, I hope you have taken the screenshots. Alright, so on the same page, I'm going to be solving part B. So part B says that by using integration by parts, show that for all the values of A which are greater than 1, the integration of ln x divided by x raised to the power 4 with respect to x, the value of this definite integral with upper limit a and lower limit 1 is always less than 1 over 9. So here we are going to use integration by parts. So as you already know that when you have been given an integration question and you are asked to do integration by parts, so the integral is in the form of u times v dash with respect to x. And when you integrate this, you get uv minus integration of vu dash with respect to x. And this particular formula is given to you in the formula sheet as well. And this particular formula for integration by parts is proved by integration as the reverse process of differentiating by product rule. And in order to decide what to keep as u and what to keep as v dash, we follow the late rule sequence. And the integration questions, particularly which involve the inverse trigonometric functions, we follow the LIATE rule. So here we are going to follow the late rule. But first of all, as we know the fact that the equation of the curve is given to us in the form ln x divided by x raised to the power 4. So what we are going to do, we are going to write the equation of the curve in this form ln x multiplied by x raised to the power minus 4, so that it is the form of u times v dash. So u is equals to ln x, therefore u dash is equals to 1 over x, and v dash is equals to x raised to the power minus 4, therefore v is equals to x raised to the power minus 3 divided by minus 3. And we can say that v is equals to minus 1 over 3 multiplied by x raised to the power minus 3. So uv minus integration of vu dash with respect to x. This is a sequence. So when we integrate ln x multiplied by x raised to the power minus 4 with respect to x with upper limit a, lower limit 1. So what we get, uv minus integration of vu dash, which means minus 1 over 3 into x raised to the power minus 3 multiplied by ln x. This is integrated. So upper limit a, lower limit 1 like this, minus the integration of minus 1 over 3 multiplied by x raised to the power minus 3 multiplied by 1 over x with respect to x. And this is supposed to be integrated. So upper limit a, lower limit 1 like this. So now we can say that minus 1 over 3 multiplied by x raised to the power minus 3 multiplied by ln x with upper limit a, lower limit 1. This is integrated, and then plus taking 1 over 3 as a common term outside, and integration of x raised to the power minus 3 divided by x. So this is supposed to be x raised to the power minus 4. And this will be integrated with respect to x with upper limit a, lower limit 1. So far we have achieved this thing. So now what we need to do, we need to integrate x raised to the power minus 4 with respect to x. So now in the next step, we can write it like this, minus 1 over 3 times x raised to the power minus 3 multiplied by ln x plus 1 over 3 multiplied by x raised to the power minus 3 divided by minus 3, upper limit a, lower limit 1. All right, so minus 1 over 3 multiplied by x raised to the power minus 3 multiplied by ln x minus 1 over 9 multiplied by x raised to the power minus 3, upper limit a, lower limit 1. So far we have achieved this thing. So now we are going to substitute the upper limits and the lower limits respectively. And first of all, you will get the expression for the definite integral in terms of a. So minus 1 over 3 multiplied by a raised to the power minus 3 multiplied by ln a minus 1 over 9 into a raised to the power minus 3. Here we have substituted the upper limit a, and then we will close the bracket and then a subtraction sign, and then we will open a new bracket, minus 1 over 3 multiplied by 1 raised to the power minus 3 multiplied by ln 1 minus 1 over 9 times 1 raised to the power minus 3. So far we have achieved this thing. So now this will be minus 1 over 3a cube multiplied by ln a minus 1 over 9a cube. Okay, and then minus sign, and since ln1 is 0, so this whole term becomes 0, and minus 1 over 9 over here. Okay, so therefore what we are left with, minus 1 over 3a cube multiplied by ln a minus 1 over 9a cube plus 1 over 9. So far we have obtained this expression. So now we can say that if we integrate ln x divided by x raised to the power 4 with respect to x with upper limit a and lower limit 1, what we get is 1 over 9 minus 1 over 3a cube into ln a, and then minus 1 over 9a cube. All right. So this is the expression for the definite integral. So as we know the fact that we need to show that for all the values of a which are greater than 1, the value of this definite integral is always less than 1 over 9. So how do we prove this statement? So here we are going to mention, since a is greater than 1, this means that ln a will be greater than 0. Ln a will be more than 0 because when a is equals to 1, so ln a will be equal to 0. So when ln a is greater than 0, this means that 1 over 3a cube multiplied by ln a is also greater than 0. And this also means that 1 over 9a cube is also greater than 0. So now we can say that I'm just going to mention the final statement with black pen. Therefore, we can say that 1 over 9 minus 1 over 3a cube multiplied by ln a minus 1 over 9a cube is always less than 1 over 9 for the values of a which are greater than 1. All right. So in this way, you will justify your statement. So this was the question number 8 of CIE P3 9709 May June 2021, paper 3, variant 3.